In this lesson, we're going to be solving absolute value equations. Now, let's remind you before we begin what we mean by absolute value. The absolute value of a number is simply the distance that number is from zero. So the absolute value of -3 would be a positive 3. Absolute value of positive 3 would also be a positive 3 because distance is always positive. So when we're solving these absolute value, let's start with these warm-ups. It says, if the absolute value of some number is equal to 7, what are the possible values? And we can use this as a guide. We know that x could be one of two things because we know the absolute value of -7 would be 7. We know the absolute value of positive 7 would also be 7, so there's two possible answers. And most of these absolute value equations will have two possible answers. However, if the absolute value of something is equal to a -4, then there is no solution for that because there's no way that you can take an absolute value and it equal a negative value. So here's our steps. Steps to solving an absolute value equation. Step number 1, we're going to isolate the absolute value. The bars, anything in front of or behind the bars, we're going to move to the other side. So we're going to isolate those absolute value bars. Step number 2, we're going to create two cases. And those two cases will be exactly what we did here, that there might be a positive or a negative value that absolute value can be. We're going to set the inside equal to both the positive and negative values of the number on the opposite side of the equal sign. Step number 3, we're simply going to solve both equations. And then step number 4, we're going to check for what's called extraneous solutions. Sometimes an absolute value equation might have extra solutions that look like it could be the right answer, but it's not. So what are extraneous solutions? Let's define that. They are solutions that do not work in the original equation. And these extraneous solutions, again, they're going to look like they're answers. You're going to solve them. You would think they're going to be an answer. But I'll let you know when you actually need to check for those because you're not going to have to check for them on every one of these absolute value equations. And I'll let you know when which ones that you're going to have to check to see if there are any extraneous solutions. Okay, solve each equation. Be sure to check, and we'll check the first one. And like I said, I'll let you know which other ones you do need to check. But again, here's what you do. Step number 1, isolate the absolute values. Make sure there's nothing in front of, nothing behind. Make sure it's over here by itself, which in this case it is, the absolute value of x minus 9. Next step, you're going to split this. There's going to be two possible solutions. We're going to say the stuff inside the absolute value bars could equal 5, the positive of this, or the stuff inside the absolute value could be -5. And again, the reason for this, if I were to take this out and ask myself, what can I put in here to make this a true statement? Then it actually turns into identical to what we were doing up here, this warm-up. What could I put inside of here to make this equal to 7? And there was two possible answers where we're doing the same thing here. What could be inside of those bars to make this a true statement? Well, the stuff on inside could be 5 or the stuff could be -5. And that's the reason we say the x minus 9 could be one or the other. So solve each of them. Move the 9 to the right. By adding 9, you get 14. Move the 9 to the right also by adding 9, and you get -5 plus 9, which is 4. So we have two possible answers here. Now on this one, I will check. Go back to your original, take out the x, put in first off 14. 14 minus 9 is equal to 5. The absolute value of 5 is 5. That's check. Yeah, that works. Plug in 4. 4 minus 9 is -5. The absolute value of -5 is also 5. Check. That works out. Number 4. Again, isolate the absolute value bars. We have. Then set the stuff inside equal to the positive of this, or the stuff on the inside could equal the negative of that. Two-step equation. Get rid of +7 by subtracting 7. And you could actually do it on both of them because it's going to be identical steps on both of them. Last step, we're going to divide by 2, and we get that k is either -2 or k could be -5. Plug those in. Both of those do work. Number 5. Now on this one, we will have to isolate. The absolute value is not by itself. It has a +17 over here that needs to be moved. So we move the +17 by subtracting it. We now have the absolute value of y minus 1 is equal to 6. Now you treat it just like you did the others. Y minus 1 could be 6, or y minus 1 could be -6. We now solve each of these equations by simply adding 1 to get rid of the -1. and you get that y is either equal to 7 or y is equal to -5. And you can plug these in and they will both work. Still don't need to check them, not on these. The next one, you have a 3 being multiplied by these absolute value bars. To get rid of multiplication, we're going to divide the other side. I now have, and do not distribute that. It'll mess our problem up sometimes. So dividing by 3 gives me a 13. Break it apart, so the stuff inside is either equal to 13 or the stuff inside could equal -13. To solve each of these, we're going to subtract the 8's, and you'll get that m is either equal to 5 or m could equal -21. Number 7. Again, we're going to get rid of 16. Since that's being multiplied, we're going to divide by 16, and you get the absolute value of r minus 5 is equal to -2. Now, this is a problem area. Go back to your second warm-up that we worked. We had the absolute value that was equal to negative. Absolute value can never equal a negative number. So anytime you isolate it, and you have to check it after you isolate it, anytime you isolate it, if you have an absolute value that's equal to a negative, you automatically know there is no solution to this equation. Number 8, now look, you've got a negative number again. However, don't assume until you isolate this. Step number 1, we have to isolate before we assume anything. Since we have divided by -2, to get rid of it, we've got to multiply by -2. You now have the absolute value of y minus 10 is equal to negative times a negative is a positive, so we're fine here. So we do split it. Y minus 10 is equal to 12, or y minus 10 could be -12. Move the minus 10s by adding 10s, and you get y is either 22 or y is -2. And again, you could take this y out, plug in both of those, and you will get true statements. Both of those do work. Number 9. Step number 1, to isolate these absolute value bars, we're going to get rid of -11 by adding 11. It gives me 6 is equal to the absolute value of 8 minus p. The stuff on the absolute inside the absolute value, we're going to set equal to 6 or -6. Now, this is one of my shortcuts. Anytime I have a negative variable to where it's just -x, -y, -p, -r, if I have a negative variable, I always move the variable. I'm going to move my minus p to the right, and I'm going to move my 6 back over here to the left. The reason I do that, negative p will turn into positive p, which is what I'm looking for. And to add or to move this 6, I'm going to do a -6, so that'll give you 2. So there's one answer. Same thing here, to move minus p, I'm going to add p. To move -6, I'm going to add 6, and that's going to be 14. So 2 and 14 are your two answers, and they both do work. Next one, you have divided by 9, so I'm going to move it to the other side by multiplying, and you have the absolute value of 3a plus 12 is equal to 0. Now, here, you can think that you're setting it equal to the positive 0 or negative 0, but 0 is a neutral number. So you really don't have to set it up twice. You can just do 3a plus 12 is equal to 0. That's going to be your only answer here. Subtract 12, divide by 3, and you're going to get a is equal to -4. I went ahead and did the 2 steps there for you. Number 11. Got 2 things to move here. Whatever you do not subtract these. This 4 is attached to this by multiplication. The 9 is not. So therefore, first step, make sure to move the 9 by doing -9. So you now have -4 times the absolute value of c plus 10 is equal to -24. Next up, since this is multiplied, we're going to divide by -4. It gives you the absolute value of c plus 10 is equal to 6. Now you're going to split it. So c plus 10 is 6. C plus 10 could be -6. Subtract 10 gives you c is -4. Subtract 10 gives you c is -16. And again, these are not the ones that you have to check. Both of those answers will work. Isolate these absolute values. First off, by moving the +8. If there's like terms, move those first, and that's going to be -24 equals -12 times the absolute value of k over 5. Since these are being multiplied, let's divide by -12, and it gives you 2 is equal to the absolute value. So since this is not a negative, we can split this. K over 5 is either equal to 2 or K over 5 could be negative 2. Solving each of these are going to give you an answer of 10 and negative 10 when you multiply by those 5s. Number 13. Now, you have the ones that you have to check for extraneous solutions. I'm going to put up here extraneous solutions. The reason this one you're going to have to check, anytime there's a variable outside of the absolute value bars, those are the ones you really need to double check to see, make sure if both of these values work. But you do it the exact same way. 3x minus 9 is isolated, so we're going to split it. So we're going to do 3x minus 9 equals x plus 1, or 3x minus 9 equals the negative of x plus 1. Now I'm going to put it in parentheses just to show you. You've got to do the negative of the whole side. So when you do that, you're kind of distributing negative 1. Another way you can do it is just change both of these. So negative x minus 1. The negative changes them both. Okay, we're going to work these individually. I'm going to move my x by subtracting x. I'm going to move my minus 9 by adding 9. That gives you 2x is 10, so x is either 5. I'm not going to circle it yet because I'm not certain. It could be extraneous. To move minus x, I'm going to do plus x. To move minus 9, I'm going to do plus 9. And that gives me 4x is equal to 8. So x could be 2. Now, one thing, a quick way to check this, absolute value can never equal a negative. So if you're ever able to plug in either one of these and it makes this negative, then that's going to be an extra solution. It's not going to work. But let's check both of these values. First off, the 5. So I'm going to plug a 5 in here. So I have 3 times 5, so I have 15. Minus 9 is equal to 6. Plug in a 5 here, you get 5 plus 1, and that is equal to 6. That checks. 6 is equal to 6. That works out. Now let's try our other value. Let's plug in 2. Take this out, put a 2, so you have 3 times 2, which is 6. 6 minus 9 is negative 3. When you take the absolute value of that, it gives you positive 3. When you plug in a 2 here, you get 2 plus 1, which is positive 3. Same thing on both sides. That also checks out. There is no extraneous solutions. The next one, you're going to have to check it again. You got an H on the outside of the absolute value bars. Check for extraneous solutions. Step number 1, though, isolate your absolute value. Multiplication by 2, let's divide by 2. Gives you the absolute value of x plus 8. H plus 8 is equal to 7h. Now you split it. H plus 8 could be 7h, or h plus 8 could be negative 7h. There's only one term that you've got to make negative. There's not two terms this time. I'm going to move my h by subtracting. Gives me 8 equals 6h. So that would be divided by 6. You get h would be 4/3. This is not going to be as fun to plug in. Over here, I'm going to move my h by subtracting, and that gives me 8 equals negative 8h. Divide by negative 8 gives me h would be negative 1. So there's my two possibilities. Now let's check them. Change colors. I'm going to plug in first off the 4/3. So you have 2 times the absolute value of 4/3 plus 8. I'm going to put an equal with a question mark about it. 14 times 4/3. The left side, 4/3 plus 8. Do 8 over 1. Get you a common denominator by multiplying top and bottom by 3. That would be 24 over 3. 4 and 24 would be 28 over 3. The right side, question mark, that's going to be 56 over 3. The absolute value of 28 over 3 is 28 over 3. So you now have 2 times 28 over 3 equals 56 over 3, and that checks out. Those are equal to each other. So that one is a solution. Now let's try negative 1, and this is going to be quick because when I plug in a negative 1, and you can plug it in up here either place. When I plug in a negative 1, I have absolute value is equal to, plugging in, gives me negative 7 over here. Absolute value can never be negative, so there is no way that negative 1 is a solution. So you do have an extraneous solution there. 4/3 is your only answer. Number 15. We are going to have to check this one for extraneous, but first off, let's move our 5 in by adding 5 in. Gives me absolute value of 8 minus 2n is equal to n plus 5n is 6n. Bring down your plus 2. Now we're able to split it. You have 8 minus 2n equals 6n plus 2. And you have, I'm going to write the other one down here, 8 minus 2n equals negative 6n minus 2. Make sure you change them both. Let's move our n's to the same side by doing plus 2n. Plus 2 turns into minus 2, gives you 6 equals 8n. To get rid of 8, divide by it, and it gives you n is 3/4. And the other one, we're going to move our minus 6n by adding 6n. Move your 8 by subtracting 8. And it gives you 4n is equal to negative 10. Divide by 4. Gives you n is negative 5/2. So now we're going to have to check both of these to see if both of them work. And you can check it in your original, or you can check it right here, either one. Okay, just don't check it where you split it. You can check it in either one of the ones that still have the absolute value bars. So plugging in 3/4, and I'm going to do this for you. Plugging in 3/4, you have 8 minus the 3/2, the absolute value of it, is equal to, and we're not sure, so I put a question mark above it. 6 times 3/4 was 9/2 plus 2. Now checking that common denominator, this would be 8 over 1, which is 16 over 2, minus 3 over 2 is 13 over 2. 2 over 1, we need a common denominator. That would be multiply top and bottom by 2 would be 4 over 2, so that would be 13 over 2. And the absolute value of 13 over 2 does equal 13 over 2, so that one checks out. Now let's try the other one. Okay, when I plug it in, 8 minus 2 times negative 5/2, a negative times a negative would be a positive, and 2 times 5/2 would be 5. Does that equal, when I plug it in on this side, I get negative 30 over 2, which is negative 15 plus 2. The absolute value of 13, does that equal, question mark, negative 13? The absolute value of 13 is 13, not negative 13. They're not equal, so therefore negative 5/2 is an extraneous solution. Okay, the last one. The absolute value bars are already isolated, so we're going to set the other side equal to the positive, or exactly what it says, and we're going to set the stuff on the inside the absolute value bars equal to the negative of this, which will be a positive 4w plus 2. Make sure you change them both. Combine your w's. To move minus 4, we're going to do plus 4. You now have 10w. To move plus 20, we're going to do minus 20. That'd be a negative 22. Divide by 10 gives you w is negative 11 over 5 when you reduce it. The other answer is move your 4 by subtracting. You're left with 2w. Move a plus 20 by subtracting. That would be a negative 18. Divide by 2 gives you w is negative 9. Now let's see if they work. Different color. We'll start with negative 11/5. Negative 4 times a negative 11/5 gives you a positive. This would be 4 over 1, so it'd be positive 44 over 5 minus 2. We've got to check to make sure that that is equal to the absolute value. Positive times a negative would be a negative 66 over 5 plus 20. Common denominators, you need a 5 on bottom, so multiply top and bottom by 5. That'd be 44 over 5, and if, I don't care, you can mark these out, multiply by 5, whatever you need to do to find common denominators. 44 minus 10 would be 34 over 5. Does that equal the absolute value? Common denominators here, multiply top and bottom by 5. That would be a 100 on top and a 5 on bottom. Negative 66 plus 100 would be 34 over 5. Does the absolute value of 34 over 5 equal 34 over 5? It checks out. This answer works. Let's try our other answer. We're going to plug in negative 9. We have negative 4 times negative 9, which is 36, minus 2. This one will be a little bit easier to plug in. Does that equal the absolute value? 6 times negative 9 is negative 54 plus 20. 36 minus 2 is 34. Does that equal negative 54 plus 20 is the absolute value of negative 34. The absolute value of negative 34 is 34, so therefore they do equal, so therefore negative 9 works as well.